Hello student. So today we are going to start a new reaction, that is second order reaction. Okay, this reaction also you have studied in the 12th standard only, but here again we'll see some of the few more points in addition to whatever you learned in the 12th standard. Okay, second order reaction. Okay, we have seen the definition of order. Now here we will see actually how the order of reaction plays very important role to study any chemical reaction if it is second order. Okay, so see what happens here in the second order reaction. It is the rate of reaction is influenced by the concentration of two reactant. Influenced by concentration of two reactant. What is influenced here? Rate of chemical reaction. Okay, if that is a second order reaction. See, the two molecules may be of same reactant or they may be of different reactant. They may be of different reactant. Not necessary every time that they must be of same reactant. See, if you see the here reaction first, it is a having same reactant. Two molecules are same. Okay, and they are reacting to give us a product. So how we can write the rate equation for that? Rate equal to K into concentration of S square, you can say. Okay, concentration of S square, you can say. What is this? K is a rate constant. K is a rate constant. Now as both of the reactant are same, reacting over here, and hence this 2 is taken over here as a square, right? Concentration of A square. Now here in this case, two reactants are there, reactant A and reactant B. They react with each other to give you a product. They are giving you a product. So how we can write the rate equation? See, rate equal to K, that is our rate constant, into concentration of A, you can say, and concentration of B, right? So you can write here A raised to 1, B raised to 1. And as you have seen, how we find out the order of reaction? N equal to small a plus small b. Small a plus small b. When two different reactants are there. What is a small a? It's a 1. Here it is, you can say. And small b, it's a 1. And a b raised to 1. So 1 plus 1 again will become equal to 2. 1 plus 1 become equal to 2. Hence the order is a second order reaction. Okay, hence the order is second order reaction. Here in this case, okay, there is only one A, right? N equal to A. So as I am writing with the help of mouse, that is not much convenient for me. So see here, what is A? It's a 2. That you can directly write here. There is no B, means no second reactant. And here is also order of reaction is second order. Here is order of reaction is second order. Okay. Now see, every time what I told you, it is not necessary to have equal initial concentration, equal reactant or same reactant. What we can say, it is not necessary to have same reactant. Okay, the reactant may be same, may be different. Here in this case, see. Now what happens? Equal initial concentration of two reactant. Whatever reactant A and B, they are reacting. They may have equal initial concentration. If they are equal, that initial reactant are same. Okay, equal initial reactant are having different moieties. Reactants are having different moieties. Okay, or two different reactants are there. So you can say this is a concentration of reactant A. This is a concentration of reactant B. Right now, see, for unequal initial concentration. Now, here in this case, concentration is not equal. What I told you, it is not necessary to have every time equal initial concentration. The concentration may be different. Concentration may be different. Okay. So, what we have seen, we are studying the second order reaction with equal initial concentration of reactant. Remember here, whatever equation you are getting after study of second order reaction, so remember here that we are getting for the equal initial concentration. Okay, now see, where A and B are the initial concentration of two reactant, small a and small b. Okay, we are considering this now to solve the equation. Okay, this is the concentration of A, this is the concentration of B. The integrated rate equation will be derived for the type 1 and type 2. For the type 1 and type 2, in which the reactant are present in equal concentration, present in equal initial concentration. Now see, type A, this is what your type A, don't get confused here. This is a type A and this is a type B, or type 2. This is type 1, this is type 2, you can say. What happens most of the time, students get confused between this small a. Okay, so don't get confused here. This is what we are considering to solve the equation only. Now see, integrated rate equation. As usual, what we have studied in the first order reaction, we are considering A as an initial concentration of reactant. Okay, as an initial concentration of reactant, that is A and B. Right? Now, let X mole per decimeter cube of each reactant A and B react up to time T. Now here we are, what we are considering, X mole of जो react झालेला आहे. Okay, a reactant, each of the reactant A and B reacts up to time T. Hence, the concentration of each of the reactant. What are the reactants? A, capital A and capital B. These two reactants we are considering here. At a time will be A minus X. A minus X. Okay, this should be small x. Don't get confused here. It should be small x. Okay, so that is what the just a printing mistake from their side. Now see, this is we have already studied, right? So after time t, the concentration of A is get reduced by X. Hence, whatever product is formed, that is A minus X. Yeah, 100 reactant react झाले, रिएक्टंट आहे आणि 100 मधले 50 रिएक्ट झाले, म्हणजे किती या प्रॉडक्ट मध्ये तयार झालेले 50च असतील, आणि जे आहेत इकडे 100 जे होते अगोदर ते किती होतील, आता तेही 50च राहतील. राइट? सो दिस इज वी हैव ऑलरेडी seen in the first order reaction. So how we can write here now? Rate of reaction is equal to dx upon dt. So this is a change in concentration of product with respect to time. Okay, change in concentration of product with respect to time. As we know that product's concentration is increasing, hence there is a no negative sign. Okay, as a reactant, if we consider reactant over here, then the equation will show you negative sign. Okay, remember here we are considering the product, hence the no negative sign. Okay, so K into A minus X. Yeah, so if you see in the above, see here A square, right? Here it is A square. And as we know that we are considering equal initial concentration, right? So concentration of A and B, when they give the product, that product, see here, now you can say here, okay, no problem. As we know that this, I just clear you over here. See, A and B, okay, they are reacting to give you the product. Okay, so this is A, okay, this is B actually, you can say, and you are getting the product. Initially it's 0 when t equal to 0, but what we said, the concentration is equal, so you can say here this is also A, this is also A. Okay, after time t, how much it will get decrease and how much it will get decrease. पहिला जो आहे प्रोडक्ट मध्ये काय होईल, एचं पण कॉन्सन्ट्रेशन काय झालेलं आहे A minus X ने, इथे काय होईल की हा जो आहे A minus X येईल, sorry, it should be X now. Product is X, here it is, and here it is also get decreased by X. So how much product is formed? See now, X into X. This is what the product is formed. But how much A and B get decreased? A मधून किती लेस झालेला आहे? A minus X. And B मधून किती लेस झालेला आहे? A minus X. Okay, so how much is the concentration now of total reactant? It's A minus X square, right? See here, what you are writing? A minus X square. Okay, now you can rearrange this equation. You take dt over here, A minus X to this side, because we have to integrate the equation. See, now dx upon A minus X square, dx upon in bracket A minus X bracket square is equal to K into dt. Rearranging K into dt, we have rearranged equation, integrating above equation. Okay, so at the initially when time is 0, concentration of X जो product आहे याचं concentration किती असणार आहे when time equal to 0? It's 0, तो बनलेला नसणार आहे, बरोबर ना? तसे दोन आहेत इथे. Now after time t, how much of the X is formed? What we are saying, that is X amount is formed. है ना, हा product किती तयार झालेला आहे? काही वेळानंतर X तयार झालेला आहे. Okay, now we know two reactants are there. Therefore, what I have written here, X into X. In that way, I have written over here. So don't get confused, please, over there. Okay, this is just for your understanding how the reaction works over there. Now, integration of dx upon A minus X bracket square, where X goes from 0 to X, where X goes from X equal to 0 to X equal to X. X goes from 0 to X, 0 to X. That is equal to K integration of dt, where t goes from 0 to t. T equal to 0 to t equal to t. So we know that what is the integration of dx upon A minus X bracket square? That is 1 upon A minus X, 1 upon A minus X minus 1 upon. See now what entries I have done over here. So initially what was the here it is A minus X. We have to put X as a X. X as a X. We are putting value of X as a X. So here A minus X. Okay, and so integrating with it now what is value of X? Here it is 0. Therefore 1 upon A minus 0. Okay, we are putting value of X first over here is equal to X. Then we are putting value X as a 0. So this is what our equation, that is equal to, again same for t. Okay, t minus 0. Okay, integration of dt is c t. Okay, t minus t, when initially t equal to t, and here at the initial after time t equal to t equal to t, and at the initial stage t equal to 0. Similarly here after time t, X is equal to X, and after at the initially X equal to 0. So solving above equation, what we are getting, this is what your second order rate equation now. See, second order rate equation. So KT, this is what the KT equal to 1 upon A. This is 1 upon A. Okay, and this is 1 upon A minus X. So this is our second order rate equation. Now this equation we are going to use for the studying the characteristic of second order reaction and to plot a graph. Okay, now see here. I'm again taking that equation over here. So this equation you can directly use, or we can rearrange above equation as. कसे rearrange केलेला आहे बघा, है ना? I am taking A to this side, A minus X to this side, okay, into A minus X into A. Okay, that is very simple. Simple rearrangement, you know it very well. You have studied in the 11th, 12th standard and even in the 8th, 9th and 10th standard. Okay, by rearranging above equation, what we are getting now? Here what happened? A get cancelled. So what is left here? Only X. And minus minus become plus. Okay, therefore X upon A minus X equal to KT. So K equal to A upon 1 upon AT into X upon A minus X. Okay, so if you want, you can use this equation also, whatever I have shown here, or we can use this equation also to study the characteristic. Now kinetic characteristic of second order reaction. This feels more convenient. This feels more convenient. Remember, the same equation would be there for you in the SY.B.Sc, T.Y.B.Sc, and if you will go to the MSc, over there also you will study the same equations for the first order and second order reaction. Okay, because that chemical kinetics is not going to leave you till you are going to study the chemistry. Okay, see now, this is what our actual equation. Okay, so from this equation, how we can find out the unit now. Sorry, this is a problem of my mouse. So, okay, see now. Okay, fine. See now. K equal to 1 upon 80. Above equation I am taking here. This equation, see, I am taking here to find out the unit. 1 upon 80 into x upon a minus x, right? That is what the equation here is, what we have simplified over here for our convenience. Now, as we know that unit of concentration, that is x and a minus x. So, this is the concentration of reactant after time t, and this is the concentration of product after time t. Remember, don't get confused. This is the concentration of a reactant after time t. A reactant ahe. This is the concentration of product after time t. Okay. Now, this concentration term get cancelled. Okay, because their unit is same. Now, see what happens here. See, this will be the number. So I'm writing here as a k upon k equal to 1 upon 80. Now this is the concentration term and this is the time. Okay. So what is the concentration of what is unit of concentration? Moles per decimeter cube. Moles per decimeter cube. And concentration unit of time is second. Unit of time is second. You can write it. And this is what mole upon decimeter cube. This is mole upon decimeter cube. You can write. Therefore, decimeter cube goes to numerator. So see here, or you can write here likewise. Decimeter cube into mole per mole into per second into per mole into per second. Getting my point? Very easy, very easy. You have to just, if you want to find out the unit of any term, no, so you have to go through the formula and you can find it very easily. And from above equation, we come to know that A is inversely proportional to the concentration of reactant now. And as the concentration of reactant increases, K decreases. Rate of reaction decreases, or vice versa. Now, so this is what we are going to study, the half lifetime for the second order reaction. What is the half lifetime for the second order reaction? So we have to use above equation here only. Whatever equation is there, no? See, this is the equation. This equation we are going to use now. Okay, and to study the half lifetime of reaction, second order reaction, we are going to use this equation to find out. See how we are using here. Now, half lifetime. Okay, so at the half time, your concentration of the product will be the A by 2. And concentration of reactant will also be the A by 2 after time t. After time t. But here in this equation, see, in this equation, K equal to 1 upon A into T1 half. Okay, where is that equation? Here it is. Okay, what I am putting here, K equal to 1 upon A into T1 half. A will remain as it is. Okay, but how much product is formed over here? Say A by 2. What is value of X? It's A by 2. X किती तयार झालेला आहे after time t? So A by 2. Here it is A by 2 upon A minus A by 2. We are putting concentration of X over here. Okay, so that is equal to 1 upon A into T1 half. 1 upon A into T1, because that will remain again as A minus A by 2 means it will remain as A by 2. Okay, so that will get cancelled. Okay, here numerator and denominator cancels each other. Therefore, this will be the equation for K. So from that we can find out the T1 half. From that we can find out the T1/2. T1/2 is equal to A 1 upon A into K. Okay, and here also see T1/2 is also inversely proportional to the concentration of reactant. Concentration of reactant. Okay, now we'll see graphical representation. How we can draw the graph. Okay, here as like a first order reaction, we are getting two types of graph. In one graph, one graph shows positive slope and other graph shows negative slope. Both the graph we can use for the study the order of reaction. And in the F.Y.B.Sc, there is also experiment we have to carry out in the laboratory. That is the same experiment would be there in the F.Y.B.Sc, and that is also there in the T.Y.B.Sc. We are finding out the order of reaction. Okay, now see here. So this is our equation for the second order reaction, right? So rearranging this equation, okay, take this term to this side, and what is the denominator is there, take this term to that side, here it is. Therefore x upon a minus x is equal to k into a into t. So I am writing here intentionally plus 0 because we are taking this as an equation of straight line. Okay, y is equal to mx plus c. Here in this case, c is a 0, so we need not to worry about. Okay, for this type of arrangement. And what is the slope? M is equal to Ka. This is what our slope, and M is equal to Ka. This is a slope. And what is x? X is a time. X is a time over here, right? Now, so here it is. Slope is equal to Ka. Therefore, K is equal to slope upon A. K is equal to slope upon A. This is what slope I told you. No, this is value of m. This is value of m. That is a slope. So you can find out here rate constant. Okay, or you can find out the order of reaction. Now see. In another way, we can arrange the equation. See, here it is. Kt is equal to 1 upon A into A minus x. The same equation is rearranged in this way. So, see, 1 upon A minus x minus 1 upon A. Simplifying this side. That is equal to Kt. Okay. So, if we are taking here, this is our rate equation. This is what our rate equation. Now, see, that is equal to Kt. So 1 upon A minus x is equal to Kt plus 1 upon A. Kt plus 1 upon A. So again we are considering in the form of equation of straight line. What is the slope here? It's a K. This is value of m. Okay, this we are going to take on x-axis. Time we are taking on x-axis. If you see on the graph, so this is graph for first type of simplification. See, here it is. This is a graph for this equation. Okay, so this is what the positive slope. Slope equal to Ka. Therefore, K equal to slope upon A. This is we have seen in above slide or previous slide. Now for this we are going to see this graph. And now 1 upon A minus x. On y-axis we are taking this. Y is equal to mx plus c. So what is the x? X is the time t. Okay, what is the c? This is the intercept. That is equal to c. In above equation, what is the intercept? It's a 1 upon A, right? And slope is a k. Here it is k. We have seen here k. Okay, so this is how we can draw the graph. We can use both the graph to find out the order of reaction. These are the general example. Decomposition of hydrogen iodide into a hydrogen molecule and iodine molecule, or again hydrogen molecule and iodine molecule react with each other to form what they are forming here, to form hydrogen iodide. Okay, now this is what decomposition of ozone to give the oxygen. Then saponification. Saponification means we are reacting with the base. Okay, we are reacting with the base. What we are reacting? We are reacting ester. Okay, so this is ethyl acetate. Ethyl acetate. This is what your ethyl. This is acetate. Okay, ethyl acetate. So after reaction you get this product. Okay, now one more reaction is there, N2 and O2 react to give twice NO, and here esterification of acid. Esterification of acid. See that acid react with ethanol to give you the ethyl acetate and water molecule. Okay, this reaction you have studied in the 12th standard only. These are what the general examples for the second order reaction. So we'll see how we are studying the second order reaction, how different terms are calculated in the second order reaction. What is here? See, see, the second order reaction with both reactant taken in equal initial concentration. है ना, दोनों reactant आहे, they are having equal initial concentration. Okay, so the time required to complete 25% of the reaction is 3600 seconds. 3600 seconds. Right? You can consider this in the minute, hour, whatever you want. But remember here to keep unit in a proper way. Okay? तुम्हाला त्या ठिकाणी final answer मध्ये व्यवस्थित ते unit mention करायला लागतं. How much time will be required for the completion of half reaction? How much time would be required for completion of half reaction? See now. How much time, what they have given us? See, the reaction is completing 25%. And what was the time required? It's a 3600 seconds. So, the concentration of reaction, that a product, when reaction is completed to 25%, is 0.25A. 0.25A. Okay, that we have seen, है ना? अगर 75% रिएक्शन कंप्लीट हुआ होता तो हम यहाँ पे क्या लेते 0.75A, बराबर ना? तो ये हमने पहले देखा है फर्स्ट ऑर्डर रिएक्शन में. You can go through the previous lecture, or there you can find it how we are calculating this. Okay, just put the value of x as a 0.25A. So here I am putting the value in our rate equation. This is what the rate equation for second order reaction. K is equal to 1 upon A into T. Now, see, what is the T? It's a 3600 second. Barabar? This is value of T. So, this is value of X. And this is also value of X. By solving above equation, what we are getting? This will come 1 upon A get cancelled. Right? So, 1 upon 3. 1 upon 3. So, this is 1 upon 10800 into A. This is what the value of K now. This is what the value of K. But we know that T1 half, what they ask for us to, how much time is required to complete half reaction? Means T1 half. T1 half, this equation we have seen, 1 upon AK into, this is what? The concentration of X after time 1 half, means half of the reaction completed. So I am putting value over here. Right? So 0.5 into A upon A minus 0.5 into A. Because what we are taking X as a 0.5A. And a 50% reaction completion is there. So hence the value of X is 0.5. 75% reaction complete hua hota, so what I should take here? It's a 0.75. 90% reaction complete hua hota, so मैं लेगा यहाँ पे 0.95. Getting my point? 35% reaction complete हुआ होता तो मैं x की वैल्यू क्या लेता 0.35A. Clear? So put the values here. This term get cancelled now. So 1 upon AK. Now you know the value of K. You are taking value of K from here over here. Okay? So that will be 1 upon A into 10800 into A upon 1. है ना? यहाँ पे आपको पता है कि K का वैल्यू क्या है यहाँ पे 1 upon 10800 10,800 is that. So 1 upon A, you are putting that value, and what you are getting, value of T1 half. See here, A get cancelled. Okay, so this is what the time required to complete the half reaction. Okay, or this is what the half time of the reaction, T1 half. Okay, now the next, we'll see one more example. So reactants are in the gaseous state now. See, they are in the gaseous state. Gas form मध्ये आहे, liquid form मध्ये नाही येते, gaseous form मध्ये आहे. So initial concentration of reactant was 5.2 into 10 raised to minus 4 mole per decimeter cube. Reactant's initial concentration दिलेला आहे. So what is observed, that 40% of the reaction was completed in how much time was required? 2700. है ना, 27 सेकंड लागले. किती रिएक्शन कंप्लीट व्हायला? 40%. Now remember here, value of x should be 0.4. See here, okay, 0.4. Now what we have to find out, value of k and time required, that is T1 half. What we have to find? T1 half. Now see, as we have equation, general equation for second order reaction, k equal to 1 upon A2 into x upon A minus x. So what is given? Initial concentration is given. A is given to us now. Okay. So A minus x is equal to A, as the reaction is completing 40%. So value of x is 0.4A. So see now here, A minus 0.4A. Right. So A minus 0.4A will become equal to 0.6A. Okay. Now using above equation, put the values only here. K is equal to 1 upon A. What is value of A? 5.2 into 10 raised to minus 4. What is value of T? Is a 2700 second. Okay. What is value of X? It's a 0.4A. And what is value of A minus X? It's a 0.6A. Okay. So what it will comes, A get cancelled, 0.4 upon 0.6. And just solving this equation, you will get the value of K. And from the value of K, we can easily find out T1 half. We have equation T1 half is equal to 1 upon AK. We have the value of A as a 5.2 into 10 raised to minus 4. And this is what the value of K. Okay, 0.4748. Okay, solving this equation, time required to complete half of the reaction is 4050 second. 4050 second. Right? This is what our second order reaction. These are what the examples for second order reaction. Remember here, we have to focus somehow more for the understanding these two graphs. Okay, you have to rearrange equations properly and then you can plot the graph. Here in the one graph we are getting positive slope. Here in this graph we are getting negative slope. Okay, this is just a arrangement of the equation to study the or to find out the value of K. Okay, and from the value of K we can easily find out the order of reaction. Okay, this is what the reason behind. Hence we are taking this. Okay, now see examples we have studied. After that, pseudo first order reaction is there. So this is enough for this lecture. Okay, for the next lecture we will see what is pseudo first order reaction. I think the reaction is clear to you. Okay, so today we'll stop here. Have a nice day.